Very good evening to all of you. Today I am going to start the subject fluid mechanics. And this subject is very important uh, for the interview point of view as well as the gate point of view. And after learning this subject, we will learn this subject here, and we are able to understand about the fluid, what is the fluid, and what are the different forces which are acting on any fluid element, and what are the momentum equations. We are able to develop the velocity distributions. Are you getting a point? First of all, we must know what is the learning objective of this subject. Before starting the subject, we must know the learning objective. So as far as learning objective is concerned, what will be the learning objective of this subject? Anyone? First of all, here I am going to discuss without wasting the time the learning of outcomes. Means after completion of this subject, we are able to know, or we are able to distinguish between the different types of fluid. Okay, we are able to understand the concept of viscosity. We are able to calculate the flow rates of the fluid flowing through any conduit or any pipe or any conduit. We are able to calculate the power of the pump required to do a certain pumping job. How much power should be required, because everyone knows fluid, or you can say better is that water has to be transport from one location to other location through a machinery called as pump. Yes or no? As far as liquid is concerned, if you want to transport the liquid from one location to other location, there should be a device that is called as pump. So how much power is required, how much power should be required to pump the fluid for a certain job? We are able to understand the principle behind the different flow meters. What are the working principles behind the flow meters? We are able to install and calculate the flow rates of the fluid with different flow meters in the closed pipelines, and different as far as different flow meter is concerned. There are venturi meter, orifice meter, rotameter, pitot tube. So there are different flow meters are there, and through those flow meters, what are the different what are the flow rates that we are able to calculate in this after completion of this subject. And also we are able to understand the different flow control devices, different control valves, like butterfly valve, gate valve, like that, na? And also we are able to understand the principles and working of different fluid flow machineries, on which principle the pump or compressors, or you can say blowers and fans, they are the different flow machineries. So as far as transportation of the fluid is concerned, there are different machineries are going to involve. They are namely pumps, compressor, blower and fan. These are the transportation devices. What are the basic differences and what are the operating principles of those flow machineries, we are able to understand here in this chapter. And also we are able to install the fluid flow machinery in the closed pipelines. Okay, and as far as also we are able to, as far as this subject is concerned, we are after completion of the subject, we are able to learn we are able to learn about the momentum equations, law of conservation of momentum, and how can we apply these laws of momentum over the fluid element, that we are able to understand here. And by using the law of conservation of momentum, we are able to develop the velocity distribution. Okay, we are able to develop the velocity distribution in the same way as we will develop, or you may have developed, the temperature distribution by applying the law of conservation of energy principle. Okay, so these are the basic outcomes of this subject. So after studying the subject, whatever the points that I had discussed, that we will able to understand. Okay, and what are the different methods of learning method? They are the learning outcomes that we discussed. Now what are learning methods? In the different learning methods are there. First of all, we will use the audio visual learning methods. Just like here we are using the blackboard here, whiteboard here, and apart from this also we are able to relate the theory with the practicals, you know. We are able to we are able to develop a bridge between the theory and practicals, so that the things will be very easy to understand and things will be very easy to visualize. Okay, so these are the learning outcome. Any doubt? Okay, now anyone have any information about the fluid? How can you define the fluid? If anyone asks to you ki how can you define the fluid, what is the fluid? Anyone? So basically, if I will define the fluid in a general, the fluid is a substance that deforms continuously when it's subjected to a tangential or shear force. However, a small shear stress may be, no matter how much small stress is. Okay, but whenever you will apply any shear stress or any tangential stress on a fluid, it has tendency to deform continuously. Not deform, it's continuously deform as long as the stress has been applied. Is this clear? So first of all, as this subject consists of two words, one is fluid and other is mechanics. So as far as fluid is concerned, the fluid is a substance that deforms continuously when it's subjected to a tangential or a shear stress, no matter how much small stress is. Even a small magnitude of the stress causes continuous deformation in a substance that substance is called as fluid. Is this clear? इन्वर्टर बंद हो जाएगा, बंद करो. देखते हैं, चलो चलो फिर देखते हैं, अभी आवाज़ आता नहीं आता है. ये लाइट फिर बंद करूँ, क्योंकि उधर लाइट बंद कर दो. तो पानी पिला देना यार, ठंडा आइस डाल के. क्लियर चल जाओ. Okay, Prajot, no matter, uh, Prajot Gajvi, sir, I never understand Bernoulli equation conceptually. Okay, no issue. Here in this lecture, you are able to learn. Okay, now, so Salja, please write how can define the fluid. The fluid, a fluid is a substance that deforms continuously. The important thing is continuously. Deformation is not a definite. Deformation is not definite. Here deformation is continuous. That's what the basic difference between the solid and fluid. My dear student, even if you apply the shear stress on the solid, है ना? For example, you may take your book in your hand. Let's say this is your book, है ना? And if you apply the stress or tangential force over the top layer of the book, obviously that will also get deformed. Yes or no? This is the deformation. But here in the solid, deformation is definite. Obviously, as long as you have applied the shear force, the deformation is not continuous. Deformation is a definite deformation is there. Yes or no? You may apply the shear force over the book or shear stress over the book, or you can say tangential stress over the book. What will you find? You will find, my dear student, कि the book will deform, but deformation is a definite deformation. Yes or no? And if you remove the force that you have applied over the top surface of the book, what happened? The solid may either regain their original shape either fully or partially. Means when you remove the load over the solid, that solid will either fully or partially regain its original shape. This is what the solid. So, but in the fluid, when you apply the shear stress on the top layer of the fluid will undergoes for the continuous deformation. Deformation is not definite. Deformation is continuous. Okay. Mr. Kajaviye. So here continuously when subjected to a tangential or shear stress. Tangential stress, or you can say shear stress. Shear. I will define what is the stress. Just wait for a moment. Stress, no matter or immaterial of magnitude of stress, no matter how small the shear stress is. Okay. Just wait. The fluid is substance that deform continuously when subjected to a tangential or shear stress, no matter how small the stress is. It means even the small stresses, even the application of a small magnitude of the stress will cause the continuous deformation in the fluid. What does it means? The two term is there. The most important keywords about the definition of the fluid is continuously, and second is what is the shear stress or tangential stress. Two very important keyword we found here is continuous deformation and second is shear stress. One by one I will clear it. Okay, so what is continuous deformation? As far as continuous deformation is concerned, let's say this is the fluid element. Let's say, my dear student, this is the fluid element. And this is the bottom layer, and when we apply a shear stress on the top layer tau, let's say this is 0, this is 1, this is 2, and this is 3. This is the nomenclature that I have assigned. This is what the fluid element. So when we apply the stress over the top layer of the fluid element, what will happen? It will cause a deformation, and this is continuous deformation. This is 1 prime, this become 2 prime. Now as the time progresses, the deformation continuously changes. Here 1 double prime, here 2 double prime. Again, if you see here, this is 2 triple prime, 1 triple prime. Okay, so what we are seeing here, the deformation goes continuous. Deformation is continuously. Once we apply the stress over the fluid element, the deformation is continuous. Means deformation is going to change with the time. This is called as continuous deformation. Okay. Okay. So first of all, as far as what is the difference between the fluid and solid from the mechanics point of view, so first of all, as far as fluid is concerned, in the fluid deformation is continuous. First point that should be noted here, in the fluid deformation, this is what fluid. Now as far as solid is concerned, here I will just compare with the solid. Let's say this is what the fluid element you have, and not fluid element, it is a element of solid. Let's say we have a element of solid is there, it is solid, and when we apply, it is solid block. When you apply the shear stress on the top layer and here bottom is fixed, when you apply the shear stress, what you will find here, deformation is not continuous, here deformation is only definite. You can see theta and theta, different deformation is there. That deformation will not going to change with the time. Okay, this is what d theta, or you can say a theta. this is let's say 0, this is 1, this is 2, this is 3, this become 1 prime, this is 2 prime, that's it. Means here in this case deformation is continuous, but when we apply the same stress over the fluid element, the fluid undergoes continuous deformation. So here in the solid, the basic difference in the fluid and solid from the mechanics point of view is that the fluid undergoes continuous deformation while the solid undergoes definite deformation. Okay, so first of all here I will write okay, deformation is continuous. Okay, means deformation will get changes with the time. Second point, the applied shear force or stress, you can say. What is the stress? I will discuss it. Applied shear stress will resist by the fluid under dynamic equilibrium condition. What is dynamic and what is static? Two types of equilibrium is there. One is called as static equilibrium, and other is called as dynamic equilibrium. What do you know about static and dynamic equilibrium? Do you know? When you apply the stress on fluid the fluid will resist, fluid will absorb that stress. जो भी stress, whatever stress you applied over the fluid element, that stress will get absorbed by the fluid under the dynamic equilibrium condition. As far as equilibrium is concerned, it's a balance of the forces, है ना. So why dynamic? Dynamic means the whatever the force that we had applied of force per unit area is called stress. I will discuss it. So whatever stress we have applied over the fluid element, that stress will get resisted by the fluid element under the dynamic equilibrium condition. Dynamic is why? Because the deformation is continuous, that's why it's dynamic. And why equilibrium? Because force is balanced, है ना. So here the applied shear stress will resist by the fluid under dynamic equilibrium condition. Dynamic equilibrium condition. Dynamic means because deformation is not definite, deformation is going to change with the time. That's why it's called dynamic equilibrium condition. Third, when we remove the load, when we remove the stress over the fluid, what happens? The fluid will never regain their original shape. Fluid will never regain their original shape either fully. Every fluid will neither fully or partially regain its original shape, except for the one fluid that is called as viscoelastic fluid. Except for the one types of special types of fluid that is called viscoelastic fluid. Means after removal of the load, whatever stress we have applied, if you remove the stress over it, what happens? The fluid will neither fully or partially regain its original shape except for viscoelastic fluid. After removal of stress over fluid element, over the fluid element, it will neither fully or partially regain its original shape except for viscoelastic fluid. Except for viscoelastic fluid. Viscoelastic fluid, the fluid viscoelastic, the fluid which have tendency of viscosity as well as elasticity, दोनों tendency होगी, that I will discuss. The example of viscoelastic fluid is Vionial fluid. That you can Google ki what are the example of viscoelastic fluid. The fluid which is present in your knees is called a viscoelastic fluid. In the knees there is a fluid is there, है ना? that fluid is viscoelastic, because when you will jump, when you are running, then that fluid will get compressed. When you remove the load and when you not running, then obviously it will regain its original shape. So that is special types of characteristic is there, that is viscoelastic fluid, and means when we remove the load over it, it will regain its original shape. Okay, but except for that fluid, no other fluid is there which have a tendency to regain its original shape either fully or partially. Okay, so that is called as fluid. Is this clear? So, and since I told you in general, all fluids will not regain its original shape either fully or partially. That's why we should say in general कि fluid is a substance which have zero memory. Which have zero memory. Why zero memory? Zero memory fluid means the fluid have not any memory. Fluid has not any memory because it has forgot its original shape. Even we have removed the load, but the fluid has forgot its original identity. That's why the fluid can be defined in the engineering languages. It is substance having zero memory or no memory. Clear? Salja, any doubt, beta? Salja, as you have asked me, when we remove the force or stress, will it deform? I told you when you remove the load, it will not deform. It will not, obviously, it will not deform. It will only deform when you have, as long as you have applied the stresses. As long as you have applied the stresses, then only it will deform. But deformation for the same stresses, the deformation is continuous. It is not definite deformation. And that's why I told you whatever the stress we applied, that stress will resist. That stress will absorb by the fluid element under the dynamic equilibrium condition. Okay. And when you remove the load, then fluid will not further deform, but also it will neither regain its original shape either fully or partially. Okay. This is about the fluid. As far as solid is concerned, this is the basic difference in the fluid and solid. Okay. And another difference in the fluid and solid is that when you start rotate the fluid, then every fluid element, every molecules in the fluid will rotate and accelerate with the same acceleration. But if you rotate the solid, the molecules of the solid will not contribute to whole rotation because molecules are fixed. That's why the term flow field, you might have heard about the flow field or velocity field or pressure field, or force field. This field means what? The region in which the molecules of the fluid, as I told you, when you allow the fluid element to rotate or accelerate through any certain acceleration or through any certain velocity, then every fluid molecules which comprising the fluid element will also move with the same velocity and same acceleration. Is this clear? Oh, sorry. I'm sorry for that. I told you for solid. When you rotate, listen. As far as solid is concerned, when you rotate or translate the solid, then every molecules in the solid will translate and rotate with the same velocity and same acceleration. But as far as fluid is concerned, when you rotate or translate the fluid with some certain velocity and some certain acceleration, then the molecules which comprising the fluid element will not follow the same velocity and same acceleration. Molecules in the fluid and solid will follow different velocity and different acceleration. That's why there is a flow field and acceleration field is there. So field means a region in which the velocities of the molecules are going to vary. This is called as field. So try to understand here. Ki what is the one more difference in the fluid and solid is that when you allow the fluid to rotate and accelerate, when you try to rotate the fluid element, what is fluid element? Anyone? What is fluid element? A group of molecules of the fluid is called as fluid element. They are enough. The fluid element is the group of molecules of the fluid element which are enough to define the properties is called as fluid element. I will discuss it. So fluid element is a group of molecules, means when we are allow the fluid to rotate and accelerate with some certain velocity and some certain acceleration, then every molecules in the fluid which comprising the fluid element will not follow the same velocity and same acceleration. They will follow different velocity, different acceleration. Okay, so that's why there is a field is there in the fluid. But in the solid, when you allow to rotate the solid with some certain velocity and acceleration, every element in the solid, every molecules in the solid will follow the same velocity and same acceleration. Yes or no? For example, if you have a book and you want to translate, if you want to move the book with the velocity of 2 meter per second, then every molecules which comprising the books will also move with the same velocity and same acceleration. But this is not the case in the case of fluids. Okay, now come to the solid here. So as far as solid is concerned, okay, one more point in the fluid you can write here. It's a 4 point. Here's applied stress is proportional to, in the fluid, applied stress is proportional to rate of strain or rate of deformation, you can say. And you might have studied in the solid mechanics, that is Hooke's law, applied stress is proportional to strain. So, but here we have added the term rate of strain. So why rate is there, anyone? Why the stress is proportional to rate of strain instead of only strain in the fluid? Anyone? Yes, very good, because it's continuous. And my son, this is called as Newton's law of viscosity. Yes, very good. Clear? So applied stress is proportional to rate of strain or rate of deformation, and that is called as Newton's law of viscosity. Okay, applied stress, now in the options they may give you first applied stress is proportional to strain, applied stress is proportional to rate of strain. The only answer is rate of strain or rate of deformation, because deformation is continuous. Okay, and that is any relationship between the stress and rate of strain, that is called as constitutive relationship. Constitutive, what is constitutive relationship? This is called as constitutive relationship. Anyone have any information about constitutive? The inherent relationship, inherent property of the system is called as constitutive relationship. Inherent property is called as constitutive relationship. Means it is a internal property कि when we apply the stress, that is proportional to rate of deformation, and that is called as constitutive relationship. Okay, So this is the point that we must note about the fluid. Now come to the solid. Here the deformation, the first point in the solid is deformation is definite. Okay, write down please first. In the solid, there is definite deformation. There is definite deformation. Applied force will resist applied force or stress, whatever you can say, will resist by solid under which condition? Under static equilibrium condition. Static equilibrium condition. Is this clear? Why static? Because deformation is definite. Third, on removing the load, on removing force or stresses, the solid may regain its original shape either fully or partially. Okay, and hence it is called as a substance having perfect memory. And here applied stress is proportional to strain, not rate of, here strain. Okay, so this is what the constitutive relationship. Any problem? This is what the difference in the fluid and solid. Now I had clear the term continuous. Now I am going to what is the stress here. First of all, we must know what is the stress. Okay, any problem, any doubt, you can ask me. That's why, since here definite deformation is there, that's why the stress is proportional to only strain. While in the fluid, deformation was continuous, that's why the stress proportional to rate of strain or rate of deformation. Okay. Omkar. Now, here I'm going to discuss, or we are going to learn what is the stress. Listen. Let's say here heading is stresses. Heading is stress. So let us consider any arbitrary surfaces. Let us consider any arbitrary surfaces. Let's say this is any arbitrary surface we have considered. Either it is surface of solid or maybe liquid or any surfaces we have considered here. So this is small differential surfaces we have considered here. Let's say this is small differential surface and its area is delta A. Differential area is delta A. This is the area of the differential area on a surface. I can also write in this way. This is better. Yeah. Clear? This is the, it is any arbitrary surfaces. On any arbitrary surface, for example, you may take your glass, and over the glass you can take a small differential element, and this is the, or you can take your book even, you can take your mobile even, you can take the wall even, and on that we have considered the small differential element over any arbitrary surfaces. And over these surfaces, the two forces, one the force which are acting is on this elemental area of delta A, the force acting on this area is delta F. Let's say this is what delta F. This is the force which is acting on this element of area delta A. If you resolve, this force can be resolved in two components. One is called as along the normal and one is called as along the tangential of this area. If you resolve this force normal to this here, it's normal to this, yes or no? This is called as delta Fn. It's normal force, normal, it's a component of the force normal to the area. This is called normal force. And other is which is along the surface or tangential to surface is called as delta Ft or tangential. ओ निहाल चार्जर लगाओ तो चार्जर इसका पीछे वायर दो छूटा है क्या एडाप्टर से इसका नहीं है इसका होगा ये है इसका ये है जल्दी लगाओ हाँ हाँ okay now so here delta Fn is normal force acting on defense area dA and delta Ft is the tangential force. Okay, and when these forces are expressed in terms of force per unit area, they are called as normal stress as well as tangential or shear stress. It means the normal stress is nothing, it's simply delta Fn, and this is called as sigma normal stress delta Fn upon delta A, where limit delta A tends to 0. Okay, normal stress. Similarly, the tangential stress or shear stress also called as tangential stress, which is called as tau, is limit delta A tends to 0 of delta Ft upon delta A. Clear? So what is the normal stress? What is tangential stress? Simple tangential stress, the force which are acting along the plane or parallel to the surface or tangential to the surface, that is called as tangential stress or shear stress. Clear? And the force which are acting normal to the surface is called as normal force, and the normal force acting per unit area is called as normal stress. So in both cases the force per unit area is there, force per unit area is there, force per unit area. Then what is the relationship between the, that question should be in your mind, कि pressure is also force per unit area and stress is also force per unit area. But my dear student, as far as pressure is concerned, I will discuss it. In the pressure, the force should be acting normal to the area. So this is what the normal stress. In when the fluid, when we applied the, or you can say, the in the case of stagnant fluid medium, in the case of stagnant fluid medium, that normal stress is called as pressure. That normal stress is called as pressure. Okay. So what the stress I am talking about, in the fluid element we have applied the tangential along the plane. बेकार हो गया अब ये।
कौन सा ये पुराना
ये वाला
पुराना कवर ये सब में इतना बढ़िया ना ठीक है चलो।
अब वो 2671 चल रहा है इसमें। Now please check. Please check. आवाज क्लियर है? निहाल निहाल, अरे इसका भी नहीं आया है, पेन वाले का, पेन वाला
इंस्टॉल करना पड़ेगा यार। तो ये आप ही तो बताए थे उसका जाएगा इंस्टॉल करना पड़ेगा। हाँ
भाई ये क्या हो रहा है यार? इससे तो लिखेंगे हम।
नहीं अच्छा
एक मिनट, इन कलर पेन, तो ये पेन यहाँ पे
इससे नहीं, इससे करना पड़ेगा, माउस से करना पड़ेगा,
अब mouse से
बहुत
निकाल
टाइम
दें।
लग गया। हाँ थोड़ा बहुत लिखना होता है। खत्म कर दो, खत्म कर दो, ये फिनिश कर दो, फिनिश
तो हाथ जल जाएगा। बुबू गरम है, छू के देखो बुबू क्या गरम है। बुबू गरम है ना? हाँ बहुत गरम है बुबू, हाथ जल जाएगा।
ये इसका माउस कहाँ गया, काम नहीं कर रहा है क्या? इसका माउस यार, हेलो हेलो,
नहीं सुबह खाएगा माँ
प्लीज़ आवाज़ चेक करिए तो। प्लीज़ चेक वॉइस, अभी कैसी आवाज़ है? हाँ भैया। हाँ वाइट दिख रही है, साफ दिख रही है ना, क्लियर आवाज़। हाँ देखिए, मैसेज कर दो। हेलो 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 हेलो। ओके। अब सही हो गया।
जल्दी हो गया होता तब भी ऐसे ही होता है, लेकिन जब हाँ वही आराम से लेट होता है जल्दी में आदमी।
मधुमंती विश्वास, ऑल गुड। तो हेलो एवरीवन, शुड आई स्टार्ट? प्रत्युषा, now we have changed the earphone, we have changed the system, we have changed the applications, everything has been changed. Now onward, we will not suffer any problem regarding this, okay? शिल्पा, शैलजा, केदार, ओमकार, इति, आदर्श, प्रज्योत, राम, हिमांशु। Okay, now, very good. Now, so as in the previous section we discussed, we had started the discussion about the stresses, है ना? I told you what is the stress that we are discussing, है ना? From here onward, you had faced the problem, I think. So what I told you, कि as far as stress is concerned, let us consider any arbitrary object. Let us consider any arbitrary object is there. Over this arbitrary object, what we have assumed a small differential element of area delta A. Of area delta A. This is the delta A, the small differential area dA over element over any arbitrary surfaces. Okay, over any arbitrary surface we have considered small differential element delta A. Is this visible to you? So you can see here, this is the small differential element, this is delta A. Okay, over this differential element, let's say the force which are acting is here delta F. Delta F is the force which are acting over the element delta A, and blur है. Okay, delta F, and we can resolve this force into two component. One is this component of the force, other is this component of the force. Sorry, I can resolve this force in two components. One is normal to this is normal, and this is what tangential. Sorry for that. This is what tangential of this force. There is two component of that force is there. One is normal to this area, and this is called as delta Fn, and this is delta Ft, which is tangential, which is tangential. So delta Fn is nothing, it is a normal force. It is normal force. Delta Ft is nothing, it tangential force. Normal force, tangential force. Okay, and delta F is a force, and its two component is there. One is normal to the surface, other is along the surface or tangential to surface. The force which are acting tangential to surface of area delta A, this is called as tangential force, and the force which are acting normal to that is called as normal force. Okay, so if these forces are going to describe in terms of per unit area, that is called stress. So what is normal stress is called as sigma, and this is what limit delta A tends to 0, and this is the ratio of delta Fn upon delta A. Is this clear? This is called as normal stress. Normal stress. And other is called as shear stress or tangential stress, which is in the limit of delta A tends to 0, and this is delta Ft upon delta A, which is called as tangential stress. It is clear. The two stresses we have found here, one is called as normal stress and second is called tangential stress. So what is tangential stress? It is nothing, it is tangential force acting per unit area, and tangential force always acting parallel to surface or along the surface, while normal force acting normal to the surface. Is this clear, Iti? So this is called as tangential stress, this is called as normal stress. And as far as tangential stress is concerned, now you may have a doubt ki what is the pressure, because pressure is also force per unit area. Yes or no? My dear student, in the pressure, the unit of stress is same as unit of pressure, because stress is also force per unit area and pressure is also force per unit area. Okay, clear? But what is the difference here? Difference, my dear student, in the pressure, the force is always acting normal to the area. So, and then again the doubt is, if pressure is the force acting per unit area or normal to the area, then what is the difference in the normal stress and the pressure? So my dear student, as far as the relationship between the normal stress and pressure is concerned, now when the fluid is at the rest, if we're talking about the forces over the fluid element, If you're talking about the forces acting per unit area, or when we're talking about the forces on the fluid element, when the fluid is at the rest, when the fluid is at the rest condition, then normal stress is equal to the pressure force, or pressure force. Is this clear? Or normal stress equal to pressure. So normal stress is equal to pressure only in the special case when the fluid is at the rest condition. You can write an important point here that I will discuss in the later on why it is so. But uh, normal stress normal stress is equal to pressure for fluid at the rest condition. When the fluid is at the rest condition, in that case normal stress is equal to pressure. Clear? Otherwise it is not equal to pressure. So what I discuss here is stresses. Stresses is simply, I told you, the two types of stress is there: normal stress and tangential force. Normal stress and tangential stress. So as far as normal stress is concerned, it is a force acting on normal to the area, and tangential stress is concerned force acting along the area or tangential to the surface of that element is called as tangential stress. So for example, if you have any object, if you have any substance, either solid or liquid, okay, let's say we are going to consider solid object, and the bottom is stationary, bottom is fixed, okay, and you had here you had applied the tangential stress tau. Here you have applied tangential stress. Why is tangential stress? Because you are applying the force parallel to the surface, okay, parallel to surface, not the normal, parallel to surface. It is called tangential stress. So when you apply the tangential stress over this, then obviously that will get deformed. Means upper layer of that substance have a relative displacement over the bottom layer. Let's say this is 1 and 1 prime, and here 2 and 2 prime. The two layer we are going to consider, one is upper layer which is 1 and 1 prime, and bottom layer is 2 and 2 prime. The bottom layer is fixed here. So when you apply the stress over that, then obviously you will found the top layer of that substance will have a displacement with respect to the bottom layer. Yes or no? So what is shear? This is called a shear. So as far as shear is concerned, the shear is nothing. It is a relative displacement. What is shear? It is a relative displacement of one layer of substance over another layer. Yes or no? Means shear is nothing. Shear means shear causes the relative displacement of one layer of substance over the another layer. Okay, that substance may be either solid, maybe liquid, maybe gaseous. Is this clear, Mr. Astosh? Rahul Kumar Singh? So what do you know about the shear? Shear is nothing, it's simply a relative displacement of one layer of substance over another layer. That is called shear. And what is shear force? The force which causes, because when you apply the force, when you pull the top layer with some force, na, you will pull the top layer with some force, and that force causes a, a relative displacement. Is this up to this? Is this visible or not? Iti. Okay, I made the boundary. Is in this boundary the things are visible or not? So sad. अच्छा, मीन्स इधर खाली जा रहा है. ओके 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 ओके. Okay, got it, got it, got it. I have to write from the most left. Okay. So again, once again, I'm writing here. Don't worry. Here I'm writing. What is shear? Shear is nothing. It is a relative displacement. Now it is visible. A relative displacement of one layer of substance over another layer. This is called as shear. Now this is clear, beta. Devis. And I told you, let's say you have any substance, let's say the bottom layer is fixed. Bottom layer is fixed, and if you are going to apply the force over the top layer, this is, let's say, tangential force. Why tangential force? Because you are applying the force parallel to this surface. That's why it's tangential force. So when you apply the tangential force, which causes the displacement of the top layer over the bottom layer, this tangential force causes the displacement of top layer with respect to bottom layer, and that is called as shear. Because shear is simply the relative displacement, means displacement of one layer with respect to another layer. That is called as relative displacement. Is this clear? So this is shear. Then what is shear force? Now come to shear force. Already I described, but here I am going to say in another way. This is shear force. The force which causes the shear. The force which causes shear. The force which causes shear, called as shear force. Clear? The force which causes shear, and shear is what? Means the force which causes the relative displacement of one layer over the another layer, that is called as shear force. So first I describe the shear, then I describe the shear force. Now what is shear stress now? Come to shear stress. What is shear stress, anyone? The shear force acting per unit area. Shear stress acting per unit area is called as shear stress. Shear force acting per unit area called as shear stress. Clear to everyone? Devis. So here I describe कि in the very starting I told you कि what is the fluid? The fluid is substance which causes continuous deformation on the application of shear stress over it. On the application of shear stress, the fluid causes continuous deformation, that is called as. So what is the shear stress that I described here? What happened, Deves? You had sent the message. So firstly, I had defined the definition of the fluid. Is the definition of fluid is very clear? And I told you what is the difference in the fluid and solid. Then I described what is the stresses. The stress is nothing, it's a force per unit area. But that force can have a two component. One is normal, other is tangential. The normal component of that force is called as shear force, and tangential component of that force is called as shear force. And when that tangential and shear force acting per unit area, that is called as stress, shear stress. Okay. Anyone have problem regarding this? Now come to the mechanics. That I had defined the fluid. Now come to the mechanics. What do you know about mechanics? Anyone, what do you know about mechanics? Because the subject comprising the two words, one is fluid, other is mechanics. Fluid I had defined. A fluid is a substance which causes continuous deformation on the application of shear force or shear stresses, no matter or immaterial of magnitude of the stress. Even the small stress causes the continuous deformation. That is the definition of fluid. Now come to the mechanics. Anyone have information about the mechanics? No, no, no. Actually, I just asked you what is the mechanics. Mechanics is the study of motion. Study of motion. It is called as mechanics. Study of motion. In general, the mechanics means study of motion. If I'm talking about solid mechanics, then it is a study of motion of the solid particles. If I'm talking about fluid mechanics, then that involves the study of motion of the fluid particles. Okay. So now, if you combine, yeah, very good, Ram. Very good, excellent. Study of motion, that is called as mechanics. So here we are going to start the fluid mechanics. Means in this subject, we are going to study the motion of fluid particles. And but as far as fluid mechanics subject is concerned as a whole, fluid mechanics is a branch of science and engineering that deals with the that describes the all the physical laws that governs the flow of fluid. Means all the physical laws that governs the flow of fluid. Means there are different laws are there, no? Which governs the flow of fluid, just like law of conservation of momentum, law of conservation of other things, na? So means any physical laws that governs the flow of fluid, and consequently it helps us to recognize the causes and effect of the flow. Causes and effect of the flow means what are the causes of the fluid to be motion, and what are its effect. So in short form, if you want to define, if anyone has asked you ki how can define the fluid mechanics, then you can say the fluid mechanics is the branch of science, and you can say uh, fluid mechanics describes all the physical laws that governs the flow of fluid Either fluid is in the motion or fluid at the rest condition. Either fluid is in the motion or fluid at the rest, and consequently it helps us to recognize the causes and effect of fluid to flow. Fluid flow, what the causes and what its effect, with the help of some characteristics parameter like velocity field, pressure field, along with the property of the fluid like viscosity, density, etc. So you can simply define here fluid mechanics. How can you define the fluid mechanics? Here please write fluid mechanics. It describes all physical laws that governs the flow of fluids all the physical laws that governs the flow of fluid and consequently help us to recognize the causes and effect of fluid flow with help of some characteristics parameter, some characteristic parameter like velocity field, pressure field, etc. with property of the fluid and with property of the fluid like density, viscosity, etc. Either fluid is in the motion or at the rest. This is the complete definition of fluid mechanics. Is this clear? So fluid mechanics describes all the physical laws that governs the flow of fluid. Okay, means whatever laws are there which follow the flow of fluids, that should be described here. Okay, and consequently means it helps us to recognize the causes and effect. Okay, what are the causes and what are the effects of the fluid flow? With the help of, we are able to describe the causes and effect with the help of some characteristic parameter like flow field, pressure field, velocity field, with property of the fluid like density, viscosity. Means we found the relationship between the property of the fluid as well as the characteristic parameter like pressure field, velocity field, and with the help of these as a whole we are able to define the causes and its effect. Okay, what are the causes, which forces are responsible for the fluid to flow? Means the main thing is that of this subject, main objective of this subject to describes all the physical laws, that govern the flow of fluid, and then it also help us, this subject also help us to recognize the causes and effect of the fluid flow. How can we define the causes and effect of fluid flow? With the help of parameters like pressure field, velocity field, along with the property of the fluid. Is this clear? This is what the major objective of this subject. Clear to everyone? Mr. Ram. This is about the fluid mechanics. Now, the next thing I am going to describe here, concept of continuum. It's very important. This is the last topic for today because today is the first lecture only. So I will describe the basic thing, concept of continuum. I will start the subject from very basics. Continuum, WM, CONTINWM, continuum. Anyone have information about continuum? Actually, the concept of continuum is a kind of idealization. So, idealization of what? Idealization of continuous description of the matter, where the properties of the matter are considered as a continuous function of space and time. So, as far as continuum is concerned, continuum concept of continuum means it is a means properties. It's a idealization of continuous description of the matter, where the properties of the matter are considered as a continuous function of space and time. Anyone have information about the continuum? Yeah, homogeneous matter or region of yeah, it is small region. You can say also it is small region in a space where the properties are continuous function of space and time, where we can define the properties, and in order to define the property there should be molecules, yes or no? If you want to define the property of a system, property of the fluid, there should be a molecules of the fluid, yes or no? If the molecules, there should be no any gap. If there is a gap, then obviously at that time, at that instant, we can't define the property. For example, try to understand here. If let's say this is small region we have considered here. Of whole screen, I have only considered small region, okay? And molecules, as you know, in the as far as fluid is concerned, the molecules are random in the nature. So molecules may at some moment it may be possible that there is no molecules are there in that region, because all the molecules may be moving randomly here and there. So it may be possible that at some moment of the time there is no molecules in that area. In that area we found there is no any molecules, yes or no? It may be possible. And in another moment there may be a large number of molecules. So there may be a probability, there may be a possibility that at any particular moment there is no any molecule is there. So at that moment, can you define the property of the fluid? Because fluid element is nothing. Fluid element is a group of a cluster of the molecules of the fluid. And in order to define the property, the condition should be in order to define the property, every time there should be a molecules at every time, and at any particular time, at any stand, at any position there should be molecules. There should be no any holes, there should be no any holes means khali jagah, space. It is clear? So what I'm saying to you, To define the property, if you want to define the property of the fluid, the control volume means, what is control volume? A small volume in a space where the fluid is continuous. This is called control volume. What I am saying you, to define the property of the fluid, the control volume should be, or you can say better is that, in order to define the property, the fluid are assumed to be continuous function of space and time. Fluid are assumed to be a continuous function of space and time. Means continuous means what? At any space, at any time, there should be a fluid molecules. That's it. So in order to define the property of the fluid, the fluids are assumed to be continuous function of space and time. It means at any given time there is always molecules should be present. It means there is no any discontinuity. There should be no any gap or holes. Okay. So this is what the concept of continuum. Now please you can write here, to define the property of fluid, to define the property of the fluid, it is assumed, to define the property of the fluid element is assumed to be continuous function of space and time. It means at any moment, at any instant, there is always molecules are present. Okay, it means there should be no, or there is no any discontinuity. Clear? Means all times there should be molecules, but obviously it depends upon what size of control volume we are going to consider. Yes or no? For example, what I'm saying to you, if let's say this is a large, you should not write this one, you should not draw this figure, just I'm going to describe here. This is a large room space. In that space, if we are going to consider a small elemental area, this is control volume. A small region in space, this is small element. Now, in that element, because here large number of molecules are there as a whole, but there may be possibility ki if you are going to consider that small region, let's say its volume is delta V. If its volume is delta V, in delta V, if delta V is very small, if delta is very small, then obviously there is a chance of discontinuity, because if this area is going to be decreases, and if delta V is going to be small enough ki there is no any molecules are there, because when it's very small, then it may be possible ki there is no any molecules are there in that small region. But when its area is going to be increases, when its delta V getting increases, then obviously there is a more possibility ki every time the molecules are there. Yes or no? So it's all about differential element that we are going to consider here. The delta V is the control volume, volume of control element, or control volume. So that I am going to describe in this way. Try to understand here. You can draw this picture. Let's say this is what the axis we have considered here: y axis, here x axis, and here z axis. Let's say this is a large space. In that large space we have considered a small differential element. Okay, my dear student, here the total mass of system is m and volume is v. But what we had considered here its mass is delta m and its volume is delta v. Is this clear? We have considered small differential element whose mass is delta m and its volume is delta v. Then in order to define the density, let's say if you want to define the density, my dear student, then what density is there? The density, because density is a homogeneous property, am I right? It's not a property of only a small element, it's a property of a whole. Means every time to define the density we can define as a total mass upon volume, and it should be also equal to delta m upon delta v, yes or no? So if delta v is going to be decreases, for example, we can define the limit. This is the delta v, and delta v should not be equal to 0, because when delta v tends to be 0, then this is the delta v differential element we have considered now. So if delta v going to be 0, then there may be a possibility there is no any molecules are there in that small differential element. If there is no molecules, then we can't define the density, because density is the mass of the fluid element, or mass of the molecules in unit volume. This is called density. So if delta v is changing to 0, there may be possibility there is no any mass is there, the density we can't define. But density is the homogeneous property. So that's why it's very important to consider delta v should not be 0, then delta v should be tending towards delta v dash. And what delta v dash, I will discuss it, into delta m upon delta v. Okay, this is what density, where delta v tends to delta v prime. Is this clear, my dear student? And listen here, if you want to define the density, if you plot this curve, how the density is going to vary with the delta v. Here it's delta v, this is axis is delta v. Clear? So when delta v is very very small, then it may be possible, when this differential element is very small, when this fluid element is very small, or this control volume is very small, there at one moment may be possible there is no any molecules are there, at other moment there may be some molecules are there. So it may be possible in that small element, at one moment there may be some molecules, at other moment there is no any molecules, and at the other moment there may be too much molecules are there. Then density is going to fluctuate. The density is going to fluctuate in that region, and beyond that it is going to be constant here. So this is the fluctuation you are going to consider here. This fluctuation is just because of molecules. Sometimes at some moment molecules may be there, other moment molecules may not be there. So this is only going to happen when delta v is less than delta v prime. So delta v prime is a critical value. So delta v, if delta v is less than delta v prime, what happen? When delta v is less than delta v prime, then what happen? Anyone? Then continuum is not valid. Concept of continuum is only valid when, because continuum says there should be no any gap. Means to define the property, the fluid element should be continuous function, or property of the fluid should be continuous function of space and time. Means to define the property, if you want to define the property density, viscosity, any property, then always there should be a fluid. Always there should be of molecules of the fluid. But when the volume of the element is less than delta v prime, then there may be possibility कि at some moment maybe fluid is there, other moment may not be fluid may not be there. Here continuum is not valid. The continuum is not valid. Yes or no? So to define the property of the fluid, the control volume should be more than delta V prime. Yes or no? Hence, and beyond this, you can say here the constant density we are going to obtain here. Hence, to define properties of fluid, hence to define the properties of the fluid, the control volume should be more than delta V dash. Control volume should be more than delta V prime. Okay, if delta V is more than delta V prime or less than delta V prime, let's say less than delta V prime, then molecules may be present, may present or not, may present or may not, may not. Clear? So is this clear? What is the continuum concept? So it's just an idealization. We are going to, so as far as the rest part of the fluid mechanics is concerned, we are always assume that fluid is continuous. Fluid is continuous. Continuum means whatever the volume of the fluid element we are going to consider, that is always more than delta V prime. It means every times there should be molecule is there. Every time molecules are present, so that we can define the properties. Okay. So as you may say कि every matter is composed of several molecules, and the concept of continuum assumes a continuous distribution of mass within the matter or system with no any empty space. That is called as continuum. Instead of actual conglomeration of separate molecules. Mr. Ram, Himanshu, Chavi. So that's why you can see here there is a fluctuation is there. This fluctuation is just because of कि that control volume is too small कि sometimes molecules are there, sometimes molecules are not there. That's why it's going to fluctuate here. But after that it doesn't going to fluctuate. It become a nearly constant. They just because of continuum. Here continuum is not valid, and here continuum is valid. Okay, so as far as continuum is concerned, we are always going to assume that fluid is a continuous function of space and time, and means every time the fluid is there, every time molecules of the fluid is there, so that we can define the property. Okay, is this clear? Now as far as liquid is concerned, because we are talking about the fluid now, the fluid is either liquid or gas. So as far as liquid is concerned, in the liquid the molecules are very closely spaced to each other as compared to gases. Yes or no? In the liquids molecules are closely spaced to each other as compared to gases. So in the case of liquids, we should always assume the fluid is continuous. A continuum is always valid, है ना? So as far as liquid is concerned, in the liquid always we can assume कि continuum is valid. Why it's valid? Because molecules are closely spaced to each other. है ना? If closely spaced to each other, even in a small volume, the molecules of liquid is always there. But as far as gases is concerned, in the gases, the molecules are not closely spaced as the liquid. In the gases, molecules are apart from each other, and there is a sufficient gap is there between the molecules. And if there is a gap is there, then there is a large chance of discontinuity. Yes or no? So in which fluids there is a large chance of discontinuity, or in which fluids the continuum concept is of in doubt? Obviously in the gases, because in the liquids molecules are closely spaced to each other. That's why we can always assume the continuum is valid in the case of liquids. But as far as gases is concerned, in the gases molecules are not closely, they are far from each other, and especially in the low pressure. Why? As far as low pressure is concerned, in the low pressure the intermolecular distance, or you can say the mean free path between the gaseous molecules are very large. As the pressure get decreases, my dear student, the mean free path between the gaseous molecules are going to increases. Yes or no? And what is mean free path, Mr. Ram? The mean free path is nothing, it's simply the average distance traveled by the molecules for the two successive collision. It's called as mean free path. Salja. So in the case of low pressure, when the gases are at the low pressure, then the gap between the molecules are getting increases, and that gap is called as mean free path. So in the gases, there is a doubt कि continuum is valid or not, and that depend upon the pressure. If the pressure is very low, means for rarefied, at the very low pressure, where the intermolecular distance, or you can say mean free path between the gaseous molecules are sufficiently large enough. Yeah, obviously gaps is very high, but even in the gases, Mr. Ram, even if you compare in the gases for the two condition, one is for a high pressure, other is for low pressure. High pressure and low pressure. So in low pressure, there is a more chance of discontinuity as compared to high pressure. So at a very low pressure, the mean free path and in that condition, since mean free path is very large, that's why there is chance of discontinuity. But at the same time, we must know at the standard temperature and pressure. What is standard temperature? 1 atm, and what is the pressure is 1 atm, and temperature is 25 degrees Celsius. At STP, my dear student, I told you in the process calculation, at standard temperature and pressure from Avogadro hypothesis, at standard temperature and pressure, 1 mole of any gas will occupy the volume of 22.4 liter. Yes or no? And the 1 mole of any gas and the total number of molecules is 6.023 into 10 to the power 23 molecules. Yes or no? The doubt of the continuum is only at the low pressure, but as compared to STP, if you talk about STP, at STP, so you can write from your own कि in the liquids continuum is always assumed to be valid, because in the liquids molecules are closely spaced to each other. But in the gases, for gases at STP, at STP, where temperature of 1 atm, pressure of 1 atm, and temperature of 25 degrees Celsius, 1 mole of any gas, 1 mole of a gas occupies 22.4 liter volume and consists of 6.023 into 10 power 23 molecules. It means in 22.4 liter, the number of molecules are 6.023 into 10 power 23 molecules at the STP condition. Then in 1 meter cube, how much it is, anyone? 6.023 into 10 power 23 upon 22.4 into 10 power minus 3. Yes or no? If you solve, then it's nearly 3.09 into 10 power 25 molecules are there. It means molecules. It means in 1 meter cube of volume. Can you imagine? In 1 meter cube, because 1 meter cube volume I can imagine length, width, and height of 1 meter. How much molecules are there? 3.09 into 10 power 25. There is sufficient number of molecules are there. And that sufficient molecules, obviously, it means in only 1 meter cube volume, there is a large number of molecules are there. Then we can assume that yes, continuum is valid, because very large number of molecules are going to be there in only 1 meter cube volume. So always we can assume here, in this case also, continuum is valid. So for a high pressure, continuum is valid, because in the high pressure, the lambda which is the mean free path, and the mean free path, it means the distance between the molecules, it's very small. But in the low pressure, the mean free path is larger. That's why there is a chance of discontinuity, maybe continuous, maybe discontinuous. Okay. So there is a large number, there is very large number of molecules are in 1 meter cube. Hence continuum is valid at high pressure and also at STP. Clear? But at low pressure, continuum may be valid, may not be valid. Is this clear? Continuum may or may not be valid. So for at low pressure, there is a criteria. Then criteria for existence of, I'm changing here, please write this. Again I'm going to here, I'm repeating, please. If it is not visible, I'm dictating here. At low pressure, continuum may or may not be valid. Okay, at low pressure, continuum may or may not be valid. Then what is criteria for that at low pressure? At high pressure, there is always continuum is valid. In the liquids, always valid. In the gases, the only problem is with the low pressure. Reason is clear why it is so? Criteria for existence of continuum is Knudsen number. It is called as Kn, Knudsen number. And Knudsen number means criteria for existence of continuum in gases at low pressure. In gases at low pressure depend on two factors. First is the lambda, which is mean free path, and second is the LC, which is the characteristic length. Characteristic length, and this Knudsen number includes the both parameters. This is what lambda upon LC, which is the Knudsen number. If Knudsen number is less than 0.01, then continuum is valid. And 0.0 means lambda is very small as compared to, means mean free path is small compared to characteristic length. And the characteristic length of the object, it may be length of the pipe or it may be diameter, anything. Then continuum is valid. Continuum is valid. If Knudsen number is more than 0.01 but less than 0.1, then that types of flow is called a slip flow. Slip flow means continuum is not valid. And if Knudsen number is more than 10, then it's called as free molecular flow. Okay. So only the part that we are going to discuss in the other part of the subject is only that reason. Means we are always in the subsequent lecture, we are always going to consider which section of the flow where the continuum is valid. Means we are always assuming कि every time the fluid molecules are present, there is no any gaps are there. Means fluid, or you can say property is a continuous, because I told you property is a continuous function of space and time. There should be no discontinuity to define the property. The property should be continuous function of space and time. Then every times, at every moment, at any point in a space, there is always molecules are there. There is no any gaps, no holes. We can define the property. Is this clear? This is what the concept of continuum. I think it is clear to you. So the problem is only with the doubt is only with the gases at low pressure or high pressure. The doubt of discontinuity is only for the gases at low or high pressure. For liquid, always continuum is valid. It's Knudsen number. Knudsen number. K is silent. KNUDSEN. Knudsen. Knudsen number is the ratio of mean free path and the characteristic length of the object. So only my question is that in which types of flow there is a doubt of discontinuity, liquid or gases. Yes, gases and gases are the low pressure, because a high pressure, Salja, at low pressure. Gases at high pressure, in high pressure always the lambda is the mean free path. It is very less, and if lambda is very less, then obviously there is always chance कि even in a small volume the molecules are there. Okay, so in subsequent lecture we are always assuming कि flow is always, or you can say the continuum is always valid, so that we can define the properties. Okay, clear to everyone? So in the next lecture we will define the properties of the fluid. Okay, what are different properties? So today I have only discussed about the basic fundamental, what is the definition of the fluid and how the fluid is differ from the solid. Okay, and then also I discussed the difference in the fluid and solid, and what is the fluid mechanics is there, and what is the continuum, concept of continuum, what is it, that I discussed. In the next lecture I will discuss the properties, because I told you कि I had already told you the learning outcomes, and after that I will discuss the fluid kinematics and dynamics as well. Is this clear? Fluid में कुछ समझ में आया? So we'll continue the next lecture by tomorrow. Okay, thank you so much. Okay, लेक्चर को कंटिन्यूस रिवाइज करते चलिए. यू शुड रिवाइज द लेक्चर कंटिन्यूसली. यू शुड, बिकॉज फॉर एग्जांपल टुडे लेक्चर इज ओनली, you should revise once, then it's clear. So you should not hold the lecture for the further revision. Okay, you should make a proper timetable कि today lecture should be revised only today, and then we'll complete that lecture. Okay, thank you so much.